UDC.
Welcome, everyone. This presentation is Harnessing the Past to Predict the Future, or how VELCO and UDC have partnered together to look at the integration of our data historian with the Esri platform.
My name is Ashkan Akaban from UDC. This presentation was initially given at IMGIS in 2025, along with another transmission company.
Great. My name is Andrew Flynn. I'm the GIS Solutions Architect at VELCO. I've been with the company for about 15 years and have just a background in computer information systems and business analytics.
And once again, I'm Ashkan Akaban, and I've been at UDC for 6 years and spent 3 of those years with VELCO, working together as partners, and it's been a journey.
During this presentation, we're going to discuss the Pi data historian and our efforts to integrate with the Esri platform and the journey that we've gone on to achieve those goals. A little bit about VELCO, or Vermont Electric Power Company. VELCO was first established in 1956 as the nation's first statewide transmission-only utility. We manage roughly 700 miles of transmission lines and over 800 miles of fiber. We have interconnections between different states such as New York, New Hampshire, and Massachusetts, but also connect with our neighbors to the north in Quebec. Our owners for VELCO are made up of the 17 distribution utilities within the state of Vermont. And these owners range from large statewide utilities such as Green Mountain Power to small municipal organizations as well in the state. So let's talk a little bit about the Pi system, or our data historian. So the Aviva Pi system, also a data historian, connects a vast array of sensors that is related to utility equipment and displays this data in real time using dashboards or other displays. And this is not only storing the real-time information, but also the historic measured values. So our goal to integrate these two systems is to provide use the Esri platform to provide a geographic context to this data, but also allow these applications to do what they do best, which is let Pi display its dashboard and complex sensor arrays, but also and allow Esri to provide that geographic information. So why is this important? I think this chart right here really shows us how the transmission system is changing. Here we have a view of the state load showing the difference between two days. On the first day, cloudy day, we see a relatively normal transmission load curve here. The next day, when it was sunny, of course, we have a massive amount of solar energy hitting the system and causing a huge drop in the transmission load for that day. So having access to real-time information and a new set of applications is critically important because our system is changing. The way that we operate our transmission system is actively changing. So let's talk about that a little bit. What's driving this change? Renewable energy growth. Vermont is looking to obtain 90% of its energy from renewable sources by 2050. And this rapid introduction of renewable energy is driving major changes in the operation of our grid. Our operators, engineers, and planners are working without complete and accurate data within siloed applications in the face of this changing grid. And our challenge is to provide all of these decision makers with a new set of integrated applications that display this data within whatever the platform they choose.
So with that in mind, to rephrase the problem, or the problem statement that we have, is that we have this tremendous amount of valuable Pi data that's streaming in from all of our smart tags and smart meters that are conveying all this valuable data that we want to be able to show, but we have a difficult time in conveying that to our GIS team and giving it in a digestible way so that to maximize the number of users that can actually receive that. So our goal is to enable our users to better access that information through our mapping applications. This is a diagram of our solution that we came up with in order to better bring that information into our applications. The key point of this diagram are the three orange circles, are the three different widgets which we've decided to set up that bring the Pi vision information, which would be critical charts and displays that Pi is able to generate. We have the historical information coming through on a historical widget that allows you to go back to certain events that have already occurred and check and see what the values were coming through our Pi system at that specific time. And we have the Pi stream widget, which is able to stream real-time information that's coming through from Pi to give us a real-time accessible information system that we can react to on the fly and see evolve in real time. So one of the big keys here that I want to point out as well is that within all this and this whole solution that we have, at the center we have our portal maps and layers, and having this specific solution really empowers us to use and rely on existing layers that our users know and love and are used to, so that when they access this Pi data through our mapping application, it feels a little bit more connected to what they use on the daily. Since we've already talked about widgets, I think that it logically follows that we must be talking about Experience Builder. So I'd like to talk about our experience problem solving with Experience Builder Developer Edition and why we selected this. There are two key factors here that I want to focus on. That's that Experience Builder Developer Edition is highly configurable, meaning that within a specific widget or experience, we're able to tune the experience to specifically fit the needs of our users. We have a variety of users and teams that will be using the application functionality and wanting to access the Pi system, but they might have different needs. They might be interested in different attributes, different features, and alerting systems might look differently to different users. That configurability allows us to highlight the elements that we're interested in for each use case. And then we also have on the other side this customizability, so that being able to customize is different from configurability in the sense that can we even get the Pi data is the question. And the customizability through widgets does enable us to get that data. Through the use of custom widgets that are configurable, we're able not only to solve our problem of getting the data from Pi, but we're also able to configure it to fit the solution of any users that need that. Experience Builder is very good at quickly ingesting a large amount of data sets, and it can handle all of the complexities behind this data that's going on in the background of the Pi system. Furthermore, since we're able to have multiple layers, we can see an interaction between the various data sets and layers and Pi values that are streaming in, and it's all visible on a map, which is a lot more easy to understand. Just to reiterate our goal, we are sharing data to empower our users, and these widgets are designed to do that, and this is how they achieve that. First up is our historical widget. This widget is enabling us to look back in time at specific events that have occurred in our map. We're able to set a start date and an end date, and then we're able to play through and see graphical changes in the symbology of the specific fields that we have set for a feature. We're able to query the Pi system to the live data as it was coming in bit by bit at a specific interval of our choosing, specific time step. And on the right-hand side, we see this Pi schema configuration. This is the configurability aspect. We're able to select and choose which attributes are important that we're able to make a useful experience to our specific users. Next is the Pi stream widget. This widget is displaying our real-time data, and in the future, we'd like to lean into this a little more heavily and try to deploy some alerting capabilities that give us real-time alerts as the system evolves, maybe potentially deal with some emergency situations so that users can be notified of anything that could require their attention and have it all displayed through this application. Finally, the Pi Vision widget deals with those Pi Vision displays that we discussed. These displays have been created by people who are working with the Pi system regularly, and they offer this rich ability to convey this data in a really, really interesting looking charts and displays that we really wanted to incorporate. This is something that Pi does well. Pi Vision is good at what it does. And so rather than recreating charts through a separate chart or line widget in Experience Builder, we opted to access these Pi Vision displays directly. This is what the Pi Vision widget is achieving. Next up, I have a demo that I'd like to play. In this demo, we're going to be looking at a specific transmission line, this specific one here. And we're going to be looking at a specific transformer, this red diamond here. And what we're interested in is watching how, using the historical widget, we're going back to a 9 a.m. start time, and we're going to be seeing the color evolve on these two. This is measuring the real power, and it's showing how the real power is going to be developing at these 1 hour steps. So I'm setting up the widget right now to get that interpolated data. And then I'm going to play through, and we'll see steps at the 1 hour interval set. We could change that interval that we want to do, but we're going to stick with that. And you can see already, if I take a step back and forward, it's already changing. And then we're going to play through that. Now, this ties in directly with what Andrew was talking about earlier. Here we see a table, and we expect to see the real power evolving over time, especially during the daylight hours when we expect there to be more sunlight. So this exactly ties into watching what kind of trends are we seeing during that time. Zooming back out, I just wanted to give an idea of what the map is doing as a whole, and that on the top right, we'd like to incorporate these alert systems so that people are able to specifically zoom into a specific substation and see what kind of problems might be occurring there at that time. Finally, I'd like to open up our Pi Vision widget. This expands out so that we're able to see our displays for specific values corresponding to our transformers. This is how it opens up. Users are able to select the time period that they're interested in looking at and walk backward and forward at that time scale. So here I have setting it to 8 hours. I can step back and step forward to see all these charts kind of evolve over time if I want to get that deeper insight or a kind of a different perspective in what's happening there.
So this platform is really providing an elegant solution that I believe allows each of these applications to do what they do best. Pi is still cataloging, tracking real-time information. It's building incredible dashboard displays that make this data understandable. And Esri is providing a geographic context to that data. It's creating an accessible platform for which users who are not engineers are able to look at a map and immediately understand what they're looking at, be able to navigate this information. We're really accomplishing 3 goals here: providing accessibility through Experience Builder and a mapping application, and data is now able to become more available to a new audience. We're connecting these platforms. We're combining the Pi and Esri data sets and providing a spatial context to this information. We're now also targeting other systems to start integrating, looking at asset management. And these applications that we were building are also dynamic. The widgets in Experience Builder offer simple configuration that can be quickly spun up. And really our next step is to identify new customers to be able to configure and deploy applications for their developing needs.
UDC